So now we're going to incorporate the 45-degree angles and what their ordered pairs are. And once again, let's write what the 4 red ones are again, just for a point of reference. Okay, so now let's look at the blue lines. So the blue lines, if you remember, are right in the middle of each quadrant, and that makes that a 45-degree angle. And if we want to name this ordered pair out here, we again need to figure out what is the x distance and what is the y distance. And that will be x and y, which will be your ordered pair of that particular point. So as you can see, we have another triangle. This time it's going to be what we call a 45, 45, 90 triangle. So let me pull that out of the picture. So there's our right triangle. And we're going to pull it down here and study it for a minute. So we have a 45 degrees and a 90 degrees. And so the other one will also be 45 degrees in order for the 3 angles to add up to 180. So what we have is, once again, we have a radius of 1 because this is a unit circle and its radius is always 1. So that puts our hypotenuse of this triangle at a measurement of 1. Then the relationship on a 45, 45, 90 triangle is that to get from the hypotenuse to one of the legs, and these legs are equivalent or congruent because the 45 and the 45 are congruent, so that causes those 2 legs to be also equal. And so when we find one leg, we'll know what the other leg is. And the relationship on a 45, 45, 90, if you watch this special right triangle video, is a square root of 2 relationship. And we're getting smaller, so we're going to have to divide by square root of 2 to get to the leg. But we need to look at that off to the side. 1 divided by square root of 2, some teachers will be okay with you leaving it like that, and some will not. And so let's rationalize the denominator to see what this looks like. And I prefer rationalizing the denominator mostly because in the 30, 60, 90 triangles, I always had a denominator of 2. And so I'd like these to also have a denominator of 2 just to be consistent. And so rationalizing the denominator, it means to multiply top and bottom by that irrational square root of 2. And what that causes to happen is you get 1 times the square root of 2 is square root of 2. 2 square root of 2 times square root of 2 is square root of 4, but square root of 4 is just the number 2 without a radical. So we've now rationalized the denominator, and so I'm going to call this leg square root of 2 over 2. And again, if you don't understand what I just did, I explain it better on the special right triangles video. So with that in mind, you now go back to your triangle in the unit circle and you see that the x distance is square root of 2 over 2 and the y distance is square root of 2 over 2. So the nice thing about that is this point will be labeled square root of 2 over 2 and square root of 2 over 2. And so what's going to happen is all the blue lines, all those 45-degree angles, are going to only involve a single number this time that you'll have to remember, which is square root of 2 over 2. You're going to always put that number in twice, sometimes with positive signs, sometimes with negative signs. And so you don't have to think short, long, because there isn't a shorter leg and a longer leg. The 2 legs are exactly the same. So that makes this one even easier. So we've established our first point as square root of 2 over 2, comma, square root of 2 over 2. That's the ordered pair that represents that point. So this point over here is also square root of 2 over 2 and square root of 2 over 2. And you have to take consideration what direction you went. So from the origin, we went a negative x direction and a positive y direction. So we want our x to be negative and our y to be positive. Then to get to this point, we did a negative direction and then a negative direction. So both x and y are going to be negative on this one. Same two numbers, just pay attention to signs. And then over here, we're also going to have the same ordered pair, square root of 2 over 2 and square root of 2 over 2. But we have gone a positive x direction and a negative y direction to get there, so the second coordinate will be negative. So you'll have a positive square root of 2 over 2, comma, a negative square root of 2 over 2. So now we have established the rest of our important points on our unit circle. So in the next slide, or the next video, we're going to put it all together and explain what these ordered pairs actually do for us.